everyone. Today we are going to do the project on data science random forest classifier on the topic customer churn prediction. Okay, so first we need to import the libraries. Here import pandas as pd, import matplotlib.pyplot.splt from sklearn.ensemble import random forest classifier. Okay, so before understanding this, we need to understand what is random forest. Random forest is a powerful machine learning algorithm used for both classification and regression problem. It works by creating multiple decision trees during training and then combining their outputs to make a final prediction. Instead of relying on a single tree which can overfit, random forest reduces error by averaging results from many trees. This makes it more accurate, stable, and less prone to overfitting. In simple terms, it's like asking multiple experts trees for their opinion and taking the majority vote. Now let's understand the importing libraries. Okay, here in this step you are importing the required libraries. Pandas is used for data handling and analysis. Matplotlib .pyplot is used for visualization like charts and graphs, and random forest classifier from sklearn is used to build the machine learning model. Okay, now next is load data. So here we load the data set df equal to pd.readexcel churn data.xlsx. Okay, here you are loading your data set from an Excel file into a data frame. Okay, this data set likely contains customer details such as tenure, charges, and churn status. Now the next is df.head. Here you can see the df.head. This line shows the first 5 rows of the data set. So you can quickly understand the structure and columns of your data. Then next is converting the target variable. Okay, here in converting the target variable, df churn equal to df churn dot map yes is to 1 comma no is to 0. So machine learning models work with numbers, not text. So here you convert the target column churn from categorical values yes or no into numeric values 1 and 0. So this step is called encoding. Now let's come to the defining features and targets. Here x equal to df tenure, monthly charges, contract type, support calls, y equal to df churn. Okay, so you split the data set into x, which is features input variables, and y target output. In x, these are the factors influencing churn. Okay, and then in y, which is the target output, this is what you want to predict whether a customer will churn or not. Okay, now after that, as you can see here, we building and training the model. Okay, so here model equal to random forest classifier and estimators equal to 10, random state equal to 42. So random state equal to 42, model dot fit xy. So here you create the random forest model with 10 trees and estimators equal to 10. Okay, an estimator is equal to 10. Then you train the model using your data. The model learns patterns between features and churn. As you can see here, there is a parameter. So the images show this hyperparameters. Okay, for a random forest classifier, which is commonly used in scikit-learn, which controls how an ensemble of decision trees is built and trained. Okay, so the core structural parameters control the size of the forest and the shape of individual trees, and estimators sets the number of decision trees to build, while criterion specifies the mathematical formula used to measure the quality of a split. Tree growth and complexity are strictly regulated by the parameters like max depth. Okay, uh, so uh, the remaining settings manage feature selection, sampling logic, and computational execution. The algorithm uses a random subset of features at each split determined by max features. Okay, uh, max features relies on bootstrap sampling to build trees on random subsets of the data and utilizes random state 42 to ensure the randomness is perfectly reproducible across different runs. Okay, so here we build and train the model. Now let's come to the making predictions. Okay, here we make the predictions. Under prediction, print prediction model dot predict 5 600 1 3. Okay, so you provide new input data where tenure equal to 5, monthly charges is 600, contract type is 1, and support calls is 3. So the model predicts whether this customer is likely to churn, which is 1, or not, which is 0. Okay, now let's then we visualize our churn count. Here df churn dot value counts dot plot kind equal to bar plt x6 0 1 no churn, churn rotation equal to 0, plt title customer churn count, plt show. So this creates a bar chart uh, showing how many customers. You can see here this creates a bar chart showing how many customers churn versus did not churn. It helps you understand the distribution of the target variables. Okay, then this is visualization true, which is feature importance. Okay, so importance equal to model dot feature importances plt dot bar x columns importances plt dot title feature importance, and then plt dot show. You can see here the chart. So this graph shows which features are most important in predicting churn. For example, if monthly charges has a higher value, it means it has a strong impact on churn prediction. Okay, so if we talk about here the insight of this chart, so the key factor influencing here the churn, if you can see, tenure 40%. Okay, tenure is 40%. This is the single most critical driver of churn. It suggests that the length of time, it suggests that the length of time uh, a customer stays with the company heavily influences their likelihood to leave. Typically, newer customers are at a much higher risk of churning than long-term ones. Okay, so monthly charges are even 30% importance. The financial aspect is the second most influential factor. High monthly bills or sudden price variations are likely strong triggers causing customers to reconsider and cancel their services. Then we come to the support calls, which is 20% importance. The frequency of customer service interaction plays a notable role. A higher number of support calls usually signals underlying product issues, unresolved complaints, or customer frustration leading directly to churn. Then there is a contract type which is 10% importance while is still relevant. The type of contract, example month to month versus annual, has the lowest relative impact among the four tracked features. So here if we take out the overall insight from the project, so that the chart clearly indicates that customers loyalty, relationship age, and financial costs dominate the churn equation, collectively accounting for 70% of the model's predict power. To effectively reduce customer turnover, business strategy should focus heavily on the early stages of the customer life cycle, onboarding and early retention, and price value optimization. Additionally, proactively addressing accounts with a high volume of support calls can serve as an early warning system to intervene before a customer decides to leave. Okay, so basically, what is the business problem and solution? The customer churn is a critical problem for businesses because losing customers directly impact revenue. Okay, Using this model, companies can predict which customers are likely to leave and take proactive action. For example, if customers with high charges and frequent support issues are more likely to churn, the company can offer discounts, improve customer service, or provide personalized support. So this helps in customer retention, cost reduction, and increasing profitability. Thank you.